Okay, welcome to the first video of section 8.5. So this is the last section in chapter 8, and so far up to this point we've been learning all about explicit rules for arithmetic and geometric series. Now, an explicit rule gives our term a rule, gives our nth term function as a function of the term's position of n in the sequence. What that means is we've always been given a rule that allows us to figure out any term in the sequence based on a formula, or just a way that we can plug in some values, and given the common difference or the ratio, we're able to figure out the nth term formula. In this section, we're going to be learning about recursive equations for both arithmetic and geometric sequences. Now, what recursive rules means are we're going to be given the beginning term, and each next term in the formula is a rule based on the previous terms. So what that means, we're going to learn how a to the n is related to the terms before it, plus either a common difference or a common ratio. So if you look at these are our recursive equations for both arithmetic and geometric sequences. So remember, our explicit rule for arithmetic was a to n equals a1 plus n minus 1 times d, n minus 1 times d. So in this case, we had to know our common difference and our first term, and then whatever term we wanted to find, we could do that based on our first term and the common difference. Here, for an arithmetic sequence, our recursive rule is our nth term is just equal to the previous term, so a to the n minus 1 plus d. Okay, so each term is just equal to the one before it plus d. This is our recursive rule. Basically, we're finding a term in a sequence based on the previous term in it plus the common difference. For a geometric series or sequence, our nth term formula is just the ratio times the term before it. So again, this is the recursive rules mean that we just need to know the term before the one we're trying to find, and then either adding the common difference or multiplying by the common ratio. Okay, so you see these rules are slightly different than the explicit rules. In geometric, a to the n was equal to a1 times r to the n minus 1, r to the n minus 1 power. This was our explicit rule for geometric. This is our recursive rule. Okay, so you need to know these equations. So these are the recursive equations, these are the explicit. So let's go back, and now that we know our rules right here, let's go back and we're going to see how we can answer these. So let's go ahead and write the first 6 terms of each sequence. So here's our recursive rule right here. So we see that each term is just equal to the one before it plus 4. So with recursive rules, you're always going to be given the first term, because in order to find out the next terms, you need to know what the first one is. So let's go ahead and plug it in here. So since we know a to the 0 is equal to 1, let's go ahead, we're going to find the next 6 terms. So if a to the 0 equals 1, that's our first term. A to the 1 must be a to the n minus 1, so 1 minus 0 plus 4. So our next term is going to be 5. Our second term is just going to be a1 plus 4, so 5 plus 4. A3 is just going to be a2 plus 4, so 9 plus 4. A4 is just a3 plus 4. A5 is just the previous term plus 4. And you see, that's how we figure out the first 6 terms in the sequence. So again, recursive just uses the previous term plus our common difference to give it this. Now, this is important because sometimes that's all you know. Okay, so this is just another way to find out the terms in an arithmetic or geometric sequence, but it's just using some different information. So you may ask, why do I need to know this if we already know the explicit rules? The reason why is that sometimes we only know certain information. So here's our first 6 terms in our recursive arithmetic. Oops, I accidentally clicked forward. So let's just look. Geometric is just, each term is just the one before it, or it's 3 times the one before it. So here, 3 is our ratio, and to get each term, we just take our ratio and multiply it by the previous term. So if we know that our first term is equal to 1, our second term is just 3 times the term before it. So we get 3 times 1 is 3. Our third term is 3 times our second term. So 3 times 3 is 9. Our fourth term is just going to be 3 times our previous term. So 3 times 9 is 27. Fifth term is just 3 times the term before it, which is going to be 3 times 27 is 81. And there we go, 1, 2, 3, 4, 5. Our sixth term is just going to be 3 times the term before that. Okay, so these are both arithmetic and geometric sequences using a recursive rule instead of an explicit rule. Sometimes recursive rules are a little bit easier because as long as you know the term before it, you can either just add or multiply a value and to get your next term. So what I want you guys to do, now that you know the recursive rules and the geometric rules, I want you to go ahead and complete these 2 questions. So I want you to write the first 6 terms of each sequence. Now I want you to label this, be very clear when you label this. So for A, use your recursive rule and write out the first 6 terms. And for B, use the recursive rule for this geometric series and write out the first, or this is geometric and this is arithmetic. So again, use your recursive rule. You're given it right here. Each term is just 1/3 times the term before it. Here, each term is just the term before it minus 6. Like I've said in the other videos, the example that we just did before it is exactly like this. So writing things like, I don't know, or I can't answer this, that's not acceptable. Just rewind it a couple minutes and watch the steps that I did, and you'll be able to get this. So again, write this clearly in the question box, label it A and then B, and make sure you just write the first 6 terms separated by commas.